Hello friends, Uncle Lee back at you with a little video on finding the volume of a solid when a region is revolved around a line other than the x and y axes. This is going to be a bit different than the previous lesson. So for this example, we're going to look at the region bounded by the graph of negative x squared plus 4, that parabola, and the constant function y equals 2. And we see that the area bounded by those two graphs is the yellow area. In the previous lesson, what we would do is we revolve what we did. We revolve that region around the x-axis. If you revolve that around the x-axis, we notice right off the bat that there is a gap. So our volume was going to be this integral from some x value to another x value of a big R squared minus little r squared. Keep in mind we have to have the constant pi out in front. And so it's just a matter of finding the big R and the little r. And then what we did is we went from the x-axis and we just went out to the farthest point of that region, and that's our big R. So our big R this time is this y value. And in this case, it's going to be that function. So big R is going to equal that function value, which is negative x squared plus 4. That's big R. Little r is this guy right here. And we notice the little r doesn't change, and little r is a 2. So little r is 2, big R is that function, little r is 2. So that gives us our integrand, big R squared minus little r squared, and then we did need to find out where those two functions, 2 and negative x squared plus 4, equals, so that we can find our lower bound and our upper bound. The little bit of analytical work there, we can see that x is going to equal negative square root of 2 and positive square root of 2. And so therefore this volume, the volume of the solid created when I revolve this yellow region around the x-axis, is given by the following integral. Excuse me. Pi from negative square root of 2 to positive square root of 2 of big R, which is negative x squared plus 4 squared, minus little r squared 2 squared dx. That was the previous lesson. Now, let's take that region, and instead of revolving it around the x-axis, let's take that region and revolve it around the line y equals 4. So now we're not revolving it around the x-axis, but we're going to revolve it around this line up here. I have that sketched on the following slide there. So this is the line that I'm going to revolve this region about. When you do these problems on your homework, I would suggest that you take a red pen and you sketch the axis of revolution. That's where you're going to start. That's how you're going to find your big R and your little r. And so this is my axis of revolution. This is what I'm revolving that yellow region around. I'm no longer revolving it around the x. I'm revolving it around this other horizontal line, which just so happens to be, in this case, y equals to 4. And I notice when I do revolve that, and that would be a funky creature to make with Play-Doh, that would be a hard one to make, but we could do it. But I noticed that if I did revolve that around that line y equals 4, what is the biggest thing? Is there going to be a gap? And yes, indeed, there's going to be a gap here, there's going to be a gap here. Now the outside of it is going to look similar to a cylinder, but this inside is going to be this curved region. But it's going to have a gap. So if it's going to have a gap, then the volume is still this. The volume is absolutely still this. Pi big R squared minus little r squared. And I'm still going from the lower bound to the upper bound, from negative square root of 2 to positive square root of 2. All I need to do is find the big R and the little r. It's the same thing. But what changes are these big R and little r. So you go back, that's what changes. You go back to your region there, and you take your pencil from that red line, and you want the farthest R. Here's big R, this case. Here's big R. I shall do that in green. You go there, and up. There's big R. There's another big R. There's another big R. And we notice that big R this time never changes. And big R and little r are always if you're revolving around a horizontal, the big R and the little r will always be some vertical distance. Some vertical distance. And we learned from 2 prior lessons that vertical distance is the top minus the dadgum bottom. Top minus dadgum bottom. Top minus dadgum bottom. And in this case, the top is 4, the dadgum bottom is 2, so big R is 4 minus 2, which just so happens to be 2, and big R never changes. It's this little r that people get confused on. And here's little r. I'm going to do little r in black. Here's little r. Well, here's little r. You start from the inside. You start from the axis of rotation and go out till you hit the region. Till you hit the region. Bam! Bam! So this little r. And yes, you are correct. Little r this time is going to change. But it's still a vertical distance. It is a vertical distance. How do you find vertical distance? Top minus dadgum bottom. So what is, and all of these little r's really are the same, because it's going to be the top, which is 4. That's the top. Take away the bottom. Take away the bottom. The bottom is this guy. This is the bottom in this case. So it's going to be, the little r is going to be top minus dadgum bottom. Top minus dadgum bottom. Top minus dadgum bottom. And that's little r. And so now I simply put big R squared into the integrand, and little r squared into the integrand. And I still have to have my constant pi, because it's all about the area of a cross section, and a cross section this time is going to be an analyst, big R squared pi, big R squared pi minus little r squared pi, you can factor out the pi, you know all that. And we still have our same balance from negative square root of 2 to positive square root of 2. Big R squared minus little r squared. It's all about the r squared. So you find your region. You sketch your axis of rotation with the red pen. You go from your axis of rotation. If there is a gap from your axis of rotation to the region, it's going to simply look like pi integral a to b. Big R squared minus little r squared dx, if I'm revolving around the horizontal. And the r's are always some vertical distance. Do not make this more difficult than it need be.